So this is a fun one. And it's been born out of my obsession about cloud and whether you're using cloud securely. Admittedly, there would be some practical advice, some guidance, and some frameworks that we built for this. But there's also some kind of philosophical, maybe soul-searching about cloud security, which I think we do need. We're going to start at a high point. I would try to very quickly and convincingly point out that cloud is secure and is more secure than any or almost any data center on the planet. Great, Anton. You succeeded. Why do we have breaches then? We'll talk about this a little bit and what it really means. I mean, cloud at this point is 15 years old, depending upon how you count, 2007, 2006. And a lot of things should be very clear to us. I'm going to have a quick detour to shared responsibility, or as my former ex-Gartner colleague called it, shared irresponsibility. And of course, shared fate would make an appearance. And then I'll offer some advice about what we can change practically in our environments to actually make your cloud use more secure. I have a lot of ammo, and a lot of this is created by my boss, Phil Venables, our CISO, about why cloud is more secure. A very classic argument that Phil makes involves 9 megatrends. There's a long blog, almost like a paper, that describes why, in his opinion, cloud is not only secure, but it's becoming more secure. And as Phil sometimes points out, people stop him and say, but Phil, you're a CISO for a cloud provider. Of course, you'd believe that. And he would always say that he believed that before he joined. That's why he joined. There's a whole multi-hour presentation that explains why there are all those trends that make cloud more secure than most data centers. Some of them are very obvious, like cloud providers have a lot of money that they dedicate to security. There's a lot of kind of virtuous circle arguments that if some cloud provider builds a security feature, there's a good chance that others would do it. The point is, I don't want to dwell on this. There are some arguments that are sort of more triggering than others. Some of you in this audience and sort of in the virtual audience may not be convinced, but to me, the jury is kind of, the verdict is in. The jury is not out. The verdict is in. Cloud, the backend, the systems, the platforms, starting from hardware up, are built with more security thinking, more security practices, more security tooling than pretty much any data center on the planet. So people say, imagine I convinced you. I think there's a separate track for the unconvinced. But we still see headlines, and some of the headlines have an amazing staying power, like Open S3 buckets is kind of a thing for 2012 and 2024. There are all sorts of hard-coded API keys and all the classic things that we see in somebody breached, cloud was involved. So for a lot of people, it creates this type of painful reaction. Maybe Anton is wrong, maybe cloud's not secure, but others don't say that. By the way, I want to do a quick detour as far as what actually happens before we discuss and troubleshoot some of the problems. We do we have a threat research project called Threat Horizons, and we do look at how people compromise our cloud instances. We look at the initial access vectors, we look at how attackers abuse it, and the results are utterly not surprising. The results are what you absolutely would expect if you, freeze in a coma in 2012 and wake up this year. It would be really similar. It would be misconfigurations, some kind of identity thing. Misconfiguration of something, including of identity. So this 2 types of issues, broadly speaking, dominate pretty much everything. Of course, there are other things. There's cloud being compromised through on-premise. My Mandiant colleagues like to point out that in the cloud, what gets you is Active Directory. And people say, whoa, no. And they say, yeah, that's what gets you because you sync identities from your on-prem to cloud. So your cloud is beholden to an older system. Like, that's a depressing news, but ultimately, it's still identity. If you're curious, and again, this is not a prezzo about this. This is sort of brings the point that, yes, there are breaches. Yes, there are compromises. Yes, there are a massive amount of crypto mining by attackers, because once they achieve the initial compromise, they likely crypto mine. Some of them steal data. Earlier today, we had a discussion about ransomware and how some of the cloud ransomware scenarios don't involve encryption. And it's a little strange because like a ransomware without encryption. And the point is that they just take the data and say, we have your data, give us money. So it's a lot easier in the cloud than the traditional crypto mining with encryption. So breaches, incidents definitely happen, whether it's our cloud or quote unquote their cloud. Another quick detour which would bring life to further discussion. There's a lot of debate in the industry about cloud threats. And our friends from CSA, I think they have a newer version from 2024, have the top cloud threats. There are many other top cloud threats. Research, again, ours, Threat Horizons, points out that just breach data, what we observe. There's a lot less hypothesizing. Some of these are very hypothetical. But when we think about this, we realize that a lot of threats are similar conceptually. It's not, yes, in some cloud, I have one cloud in particular I'm thinking about, multi-tenancy issues would probably get you, but it is an exception. Ultimately, what sinks you is probably the fact that somebody forgot a credential in code, not because there's a multi-tenancy weakness, except for this one example. But threat modeling for cloud is kind of a must, because if we say, you are doing security in the cloud wrong, you have to also imply against what threats. So threat modeling comes up, and this is, again, I said it's kind of a detour from detour, but the point is that, as you'd see at the end, to achieve a more secure use of cloud, to achieve secure use of cloud, you would have to gain awareness about what threatens your use of cloud. Not cloud in general, not what can possibly happen in the cloud, but like what happens your specific use of cloud. The classic answer to this is, before I go there, the classic answer to this is, sorry, too many clicks again. The classic answer to how the responsibility is divided is to say, cloud is secure, and here's what the provider is responsible for. And here's the part that the client is responsible for. And my former colleagues, which in this case means Gartner, would like to point out very often that most cloud security problems sit on the customer side. And there's a lot of very beautiful, very pithy, very crisp statements by both current and former analysts that point this out. And I'll show some of them later. But when people show shared responsibility, when somebody writes a paper and says, shared responsibility is powering cloud security, this is security provider does, this is security you do, and then you say, yeah, I got it. And then you have something of that sort, which is completely made up. I just made it up to be extra inscrutable. But if you have a SaaS provider monitored by somebody, and somebody built it in some cloud, but certain components is in another cloud, who does security for this? Like, nobody really knows. And beautiful two-color tables or two-color visuals about this is me, this is provider, kind of go out of the window because reality barges in. And the reality says, well, it's a SaaS provider that backends to IaaS, a simple case. OK, cloud provider is responsible. Which of the two? A SaaS cloud provider or IaaS on the backend? Some of the breaches from a few years back involved IaaS mistakes committed by a SaaS provider that you use. So that already starts to look a little tricky and a little less clear, and not like cloud customer. This is something that at this stage, in this presentation, it sort of gives context to the fact that it's a lot trickier than people assume. And there's no, this is you, this is me, because there's many me and many you in this case. So when people say, it's very clear, shared responsibility, and they pick an example like hardware security. Who protects hard drives in the data center against being stolen? Yeah, that's a provider. It's very clear, very crisp, very black and white, very binary. Yes, no. But then you start moving, and then a lot of things become very fuzzy. So if somebody shows up, whether it's your boss or somebody from your team, and says, it's clear how to apply shared responsibility model, probably don't believe them, because in many cases, there's a lot more nuance. And that nuance ruins what you'd see in a few moments about how to do secure use of cloud. So people have, I'm going to go out of order a little bit. Sorry, maybe too much out of order. People go and basically say, some of this is not about cloud being secure. Cloud is secure. And this is the one example Gartner quote. The first version of this was introduced in 2015. I checked with the person who coined it at Gartner. He also retired already. And it's interesting that he gave a date in 2015 and a date I think was 2017. And then Gartner over time basically just pushed the date, and now the current version says 25. I would bet you $20 that next year this would still be true and the number would just be larger. The year number would increment. This statement is, reading this, and when I was at Gartner, I saw this line many, many, many times, and I always nodded and said, yes, I agree, this makes sense. The fact base, the Gartner term for, well, facts behind this is very solid. It's kind of true. But as somebody wise pointed out, it sounds a little blamey. So it may be true from factual point of view, but is it a good way to think of the world? It's, if I'm the provider, I built the cloud, I have organized, built security features, I built foundational level security, I built a secure platform, I've given controls to clients, and then you use the cloud, you get compromised, and you, because your developer left hard-coded key in PHP script. Probably not PHP, by God, let it not be PHP. Some other code. Can you really say cloud is not secure? No. Can you say provider's at fault? No. It is true, but it's also the statement that constrains development. Like it constrains progress. So what can we do? It's less about fault finding. It's more about how do we make it better? How do we make better cloud? How do we have more secure use? And if you think, naively, by the way, that cloud providers are interested in this being true, no. Because the more people have secure cloud experience, the more cloud they use. So ultimately, we are also a stakeholder in making secure use of cloud widely spread, more popular, easier. In this case, it isn't about blame. And a fun example, which I did not put on the slide just not to annoy some people. You probably observed a recent Snowflake debacle in the news. By the way, in certain news sources, it was reported as Snowflake breach, but of course it was not. But the interesting point about this is that half of the press articles had the vibe that there was this cloud provider, cloud storage provider, that had some kind of problem. And the other half reported that some customers of that cloud provider suffered breaches. And to me, it was almost like an interesting way to observe two types of reporting and say, wait a second, so this is like shared responsibility comes to life. But it also comes to life in a very painful way because there's no consensus how to think about it. I have the provider in question built MFA. Somebody didn't use it. Do they have responsibility for pushing it harder? I don't know. How hard do you want? Let's make it mandatory. These applications break. People demand they unset it. So a lot of this is much harder in real life. And I mean, the Snowflake debacle is a great example of where these forces kind of clashed. And I don't know ultimately who the general IT population thinks is at fault. But it's a very crisp, well, it's the opposite of crisp. It's a very fuzzy example of responsibility not being clear. And that's what I want to evolve to something better. By the way, this presentation is has a lot of detours, and this is one more fun detour. Over the years, as I was talking to people about this, I realized that there are still two camps. And there is still a camp of cloud is insecure, there's no debate. A lot more of those people kind of decreased after maybe 2015, 16, 18, when cloud started to become mainstream. There's more tooling, more vendors. But I still see a very uncommon but occasional person, maybe in Europe, maybe in regulated industry, where they sort of say, yeah, we don't believe in this cloud stuff. And very, very much a minority opinion, but it's really there. However, the opposite myth occasionally happens. The CIO reads the proverbial airline magazine, reads the cloud is secure correctly. Maybe they quote Phil Venables to say that GCP has the best security on the planet, and it is. And he thinks if we shift our servers as VMs to the cloud, we suddenly become much more secure. Yeah, no. So a lot of this frames this problem, but doesn't help us answer it. So at this point, we have most of the time left, so let's try to actually answer it without making use of the myths. These people really, really annoy me, by the way, the myth for believers. namely that it's the camp that believes that to have secure experience in the cloud, they have to grab every single thing they had on-prem, chain it to a tractor, and drag it to the cloud and deploy it. And I really mean sniff every packet, deploy agents on every endpoint, and do everything else they do in a data center for a well-architected security stack circa 1990s, 2010s. They're wrong, and not only because they spend a lot of money doing this, but because they double down on some of the cloud strengths. They may re-encrypt things that are already encrypted really well, but they may miss things that are just parts of a different reality. As a quick side comment, I also run a podcast for Google Cloud called Cloud Security Podcast. A long story why the name is so original. And on this podcast, we often really ban people who say cloud is just somebody else's computer. And the reason we hate this line is because of the line just, is because of the word just. Cloud certainly involves somebody else's computers, but a cloud-native, cloud-first environment is not just somebody else's computer. There's a lot of stuff built, a lot of abstraction layers, a lot of things that point out the different operational practices. So to me, replicating an on-premise stack to cloud is not an answer to secure use of cloud means I have everything I have on-prem. So let's start focusing. Like, I think I've given you a lot of detours, a lot of some ideas, hopefully some useful. Let's try to focus. What entails secure use of cloud? What should one do to claim or to confirm to themselves and others that they use cloud security? And what should one not do? Again, replicating the entire on-prem stack is probably more a not do, but the argument for that's unclear. Like, why not? It works here. Why wouldn't it work there? So let's go through a journey, and then I promise there will be an answer. Again, my former colleagues, Gartner, have given it a lot of thought, and so did Forrester, IDC, a lot of other firms, many consulting firms, Deloitte. You can find a lot of materials on what it means to deploy things securely inside IaaS. As I was going through them, dozens of them in various forms, I realized that a lot of them have kind of on-premise DNA. And this shows up in certain elements that clearly carry over from the pre-cloud realities. When the IT pace of change was slow, there was no DevOps. There were developers, there were system admins. Security was mostly appliances and software you deploy on servers. There are definitely glimpses of securing APIs or something that's much more modern. But a lot of the rest of the stuff seems inherited in the bygone era. So and also it seems very complicated. And it kind of reinforces the group I've called the kind of myth 4. Replicate your on-premise security stack to cloud, only then you're secure. Unless I have my EDR, NDR, IDS, firewall, SIM, PAM, whatever other acronyms I can coin or remember, I'm not secure. I think that's first thing, not the answer. It's also not the answer people actually do when they're maybe a smaller company. So this is a very uncooked version. I've been kind of talking to various people, looking at how others do it. And one thing that came up is that unless you know cloud, you probably cannot have secure use. If you have some kind of delusional view of cloud being a rented data center, kind of like my data center, but run by some other company, a lot of the rest won't matter because you'd immediately go down the path that won't get you there. It's kind of like you may meander, but the destination won't be secure use. The destination would be some kind of a mythical cloud that doesn't exist and you. A lot of other things seems very logical, but again, things get kind of complicated. Asset management comes up. So this version people kind of liked. They definitely appreciated the role of knowing cloud. And then I thought, OK, what you really mean is this. And this is what I ended up with. I ended up with saying, as some of you know who maybe saw me write or saw my writing or heard me on the podcast, I kind of have a 3 a.m. answer. And that means if somebody wakes me up at 3 a.m. and says, Anton, describe secure use of cloud quickly, I would probably describe something that has what you have in the cloud, knowledge of assets. You place a lot of importance in IAM. Remember the threat horizons, breach data, identity mistakes. You put a lot of attention to configuration management. Again, look at threat horizons and other data sources. You are still doing it in a more modern way or more legacy way. If you are more lift and shifter, maybe scans are slower, less pipelines, more finished machines, but you still have CSPM. You would have to do a fair bit of AppSec. AppSec is escalated in importance because you do have a lot less configure Windows securely, a lot less secure OS, but you have a lot of AppSec, and because of wide open source use in the cloud, the supply chain security comes up, and basically, to me, it's part of AppSec. Other people argue about this, but the fact that you don't want open source, I think I have to have a pager joke. I cannot not have a pager joke. You don't want open source pagers in your supply chain. So, and then data security comes up. A lot of people say, well, yeah, duh, obviously data security is important. Data security is, to me, important. But admittedly, if I have to give a shorter answer, I would give IAM and CSPM, configurations and identity, which almost matches perfectly to threat horizon data, but it also matches to general awareness of what are the cloud breaches, how people suffer. And then given that I spent so much time inside SIM tools and SOCs, there would be a DNR layer. Some people who claim that if they do 1, 2, 3 really well, in a really beautiful modern way, IAM is just magically good, CSPM, configurations are remediated within milliseconds, and AppSec is done by the best of the best, then they don't need DNR. They're wrong. You still need DNR. I mean, the detection response would stay simply because doing it well is possible, doing it perfectly is not. So to me, that's really the short answer. You have asset awareness, which is fortunately much easier in the cloud than on-prem. You know what you have in the cloud. You don't have servers in the closet in the cloud, but you do have cloud accounts when somebody swiped out a credit card and purchased cloud. So there's a bit of trick to this, but at least we know what to do. We roughly know what to do in IAM. We approximately have guidance and a lot of vendors that focus on configuring cloud, remediating configurations. AppSec remains to be tricky, but at least we know this. And then data security is strongly backed up by cloud tools. So this is good. It's a good short answer to somebody, what's secure use of cloud. There's always one person, maybe not always, but often, who is a former network engineer, and then he spent 10 years configuring IDS and firewalls and says, Anton, where's NetSec? NetSec's not here. Sorry, guys. NetSec plays a role. There are network access controls. There's firewalling code. There's VPCSC. There's a lot of other fun stuff. To me, it just doesn't make the top list. It's on the list just as well configuring Windows securely if you have Windows in the cloud. But it's not in my 3 AM set. I won't think, and by the way, make sure you have good network access control. And if I would say that, it would still boil down to IAM. Ultimately, I want multiple layers. I want something like our org policy, default deny, a lot of other stuff. So NetSec plays a role, but to me, NetSec is auxiliary, not primary. And these boxes are primary. People said, OK, Anton, that's good, but maybe it's good for CISOs. We are network engineers and architects. We want a good answer to the next level of detail. So I've tried to craft a few things that, to me, may not make my 3 AM answer, but it would make me short advice I would give if somebody says, OK, I kind of like your visual. Tell me how to do it. I went on a quest, not to Himalayas or deep cave, but I went on a quest of asking lots of people who deal with IAM about what does it mean to do IAM right in the cloud. That proved very difficult. Some people were willing to sacrifice the principle of least privilege, and that's a long story, why and how. But they wanted to point out that there better be a simple roadmap, top-down roadmap for doing IAM right. And I think it boiled down, after all this, to persona-based access. You're not doing John can touch system X and Y because you're going to drown right away. On-prem, you drowned within a year. In the cloud, you drowned within seconds. So persona-based access, and another person brought up small roles, no all-powerful admin of everything or even of something. These, to me, are probably not big secrets. There's a lot of stuff we wrote, other people at GCP, and I'm sure people at other cloud providers, about how to actually do that. But to me, that's what I distill it to. In config management, apart from scanning, remediating, a lot of this has kind of practical answers, but they have a lot of dependencies. What I mean by don't on-prem it. I've met enough people who want to use the scanner or some kind of assessment tool, perform periodic assessment, send the reports to somebody in the quote-unquote cloud team, have them fix the problems, and then report success. That doesn't really work, even in moderately cloudy cloud. If your cloud is truly a carbon copy of the data center, it may work. But if your cloud is at least a little bit cloudy, that would break very quickly. You would think about 800,000 issues that are different every day and hard to prioritize. And the point is that you are still doing it in code. To accelerate this pace of configuration change, a lot more cloudy elements have to get in. You are not doing the server patching faster. That's probably impossible. But you can patch code and pipelines much faster. On the DataSec, there's mostly good news. Funny enough, the DataSec bucket is just like a bucket of good news. Data discovery is much faster, much easier, much more effective, much more accurate, and much cheaper in the cloud. So basically, like good, fast, cheap, everything else, pick all of them. That applies to our cloud. It applies probably to other clouds as well. You're not supposed to have unknown sensitive data in the cloud. A lot of stuff is very easily scanned, yet at the same time encrypted. To me, the pervasive encryption is a very good sign of why DataSec in the cloud is just better flat out. There was a survey by some vendor who claimed that some percentage of customers' data in the cloud is unencrypted. And I'm like, that's false, because say in GCP, you can't have unencrypted data. All data is encrypted. Every machine that runs cloud has encrypted drives. So who manages the keys? Separate story. But you can't say we have unencrypted data. We don't. So a lot of this is just good news. To me, most of the tricky to do but must do it anyway kind of sits in the AppSec bucket and in the configuration bucket, and how to make this run faster, how to prioritize better, how to run better algorithms so that you fix issues that affect your cloud. This is kind of the next level of detail. I'm sure at some point we'll have a lot more guidance and a lot more things, and yes, of course, helpful products to buy. But to me, this is the short, conceptually understandable answer. You can show it to your boss, you can show it to your boss's boss, and then you say, if I don't do this, I probably cannot claim that I use cloud securely. So you look back at the line, most breach is a customer's fault, a cloud user's fault. Doing this would sort of try to squeeze this to a smaller element. I do want the attackers to work much harder on trying to compromise either your environments or our environment. I mean, our environment's admittedly much harder already, but the point is that I want all of the environments to be harder so attackers will go elsewhere. So to me, this is a step in that direction. And it also gives a lot more clarity to an otherwise very philosophical point. Hey, just do it better. Like, what does better mean? We have, I have time for this whole another detour that's very useful. When people ask us about how Google does something, we've run a podcast about how Google does cloud security. It was a very popular episode because people assumed we had some kind of deep, dark secrets about how we use our own cloud. And we do. And the interesting bit about this is that some of the things we do is also not magical once you realize how the rest of our organization is put together. So some of the stuff is easy and logical once a lot of other things are built. And if they're not built, the steps seem impossible. So to me, that's why adopting some of the elements kind of does involve a culture change. And I think we had a blog post somewhere about why culture trumps technology transformation, even trumps people and processes being a kind of an overlying umbrella over that. To me, this is the painful part of an answer to a technologist in the room, including myself, because I realize that if I am used to data centers and data center processes and my people are used to that, culture change is hard. And unfortunately, I was on somebody else's webinar earlier today, and there was another speaker who once confronted with this question basically said, it's generational. People must die, and their children must be born and know this. It was a depressing answer. I'm a pretty cynical guy, but I think to me that took the cake. I'm like, whoa, what do you mean? Like, that's all hopeless? We just need to wait for people to die? Like, that's dark. But his take was that culture change is so hard that some organizations, it's never going to happen. If they move to cloud as lift and shift, and they hope to later adopt more cloud-native operational practices and skills and technologies, that may be a multi-year journey. This is a detour, but it's also a detour that reminds us that some of the tech changes won't work as tech changes. A scary example, also learned on our podcast, was somebody did research about container security, and they realized that 54% of containers had SSH access. To me, that was kind of like, if it's the same joke you've heard before, it's like 54% of zoos have dragon in them. Like the real number should be 0. There shouldn't be any number other than 0. You don't SSH into containers. That's not what containers are for. But the data collected by this vendor was a large percentage of containers had SSH access, which means they adopted the tech stack of the modern era, but they did not change the practices. That means they succeeded at tech stack change, but they failed at culture change. And this, to me, is a useful, again, little depressing example where some of the stuff requires deeper changes in the org. And it's not about Anton flashing a diagram like this and saying, hey, here's the 5-step process, just do that. Ultimately, certain steps have dependencies that are a lot trickier to do. So I'm sure some of you would have questions, so I'll save time for that. If I'm trying to build an even simpler, sort of like, again, 3 AM compliant view of what does it mean, know what you have in the cloud or clouds, likely it's multiple. Be aware of cloud threats to your cloud use. To me, the threat assessment angle comes up because a lot of controls and a lot of importance and comparative importance, do I do more IAM or configuration? How do they play together? Relies on the cloud threat assessment. And then configuration, IAM, and DNR layer that you have to have. This is high level and a little fuzzy and also multicolored to make it more fun. But ultimately, this allows for a minimalistic answer for secure use of cloud, probably this. If a vendor shows up and says, unless you have, I'll pick an example. I've met a vendor who secures SLM. I had to ask him, what's SLM? And they say, it's a small language model. They build a security tool set to protect SLMs. So like, probably not high on the list, to put it mildly. The point is that these things are high on the list. Doing IAM in a way that scales, rapidly remediating configuration weaknesses, having a semblance of understanding about what the threats are, having a very clear understanding of what you have in the cloud, and running DNR on the threats you discovered probably would give secure use of cloud, at which point the breaches and the attackers would have to go work much harder rather than just rely on S3 buckets or credentials and code. That's what I have. There's some writing on this, but ultimately you can pick it from the deck. Any comments, questions, wishes for the future? Oh, cool. If it was very off or, OK, sure. I think, yeah, threat horizons, I'll flip to that. I would expect for data centers it to be different because credentials, you're not going to help you all that much. I mean, there would be a lot heavier network boundary penetration. Like if I have robust firewalling and I manage it well and it's internal to internal only, a lot of this would have to go back to NetSec if I am in the data center. So it probably would be misconfiguration of some form, but misconfiguration of different things. There would be a lot less IAM, except maybe against insiders, than it's IAM again. So it's a good question how this chart would look for data centers. Probably would have a lot more of the mistake with firewalling, mistake with misconfigured firewall. Somebody dropped allow all in the middle instead of in the end, or instead of deny, they said allow. So there would be a lot of NetSec, a lot of network configuration, a lot of they turned off IPS, or this is one thing, would be a lot less IAM. And DataSec would play a role, but I don't know exactly how DataSec would change. So that's an interesting question, how the same ways in. I mean, there would be a lot of phishing, but phishing is a tricky one because ultimately with phishing, you can get in the cloud as well. If you phish proverbial AD credentials, you are probably getting in the cloud as well. Again, my scary slash favorite Mandiant example where a lot of cloud hacking is AD hacking. So that means also data center hacking. Yeah, but that is a good question. So like, what changed in that threat model when we shifted to cloud? I mean, API abuse probably here may fit in the credentials because some of the API abuse is a subset of credentials, would probably be non-existent for data center because there's not that much publicly exposed APIs in a typical data center. Yeah. I mean, physical security is missing here, obviously. Would be a small sliver, but still very small. Like you're not stealing the hard drive from us, but they're probably not stealing the hard drive from you either. So it's probably a wash, yeah. Yeah, sorry, go ahead.
With regard to the misconfiguration fees, given the large value of number of initial access vectors, what are some ways to do the scanning? So is there tools within GCP, for example, to do the scanning and get some sort of baseline, or is that baseline dependent on the IT organization saying what tools are?
So the answer is basically yes to both. We have tools that cover GCP. We will have tools, and we are having tools that cover other clouds so that this stack can be multi-cloud. But there would be dependencies to, like if you wrote an application yourself, then the misconfiguration of that application is not on us. Like it's conceivable that in the future we'll tell you to not write this application or write it differently. But today, if you wrote an app configuration is on you. But if it's a platform something or a component that comes from us, then it's a joint responsibility where we play a larger role. Again, when we talk about shared fate, it basically means we help you with things that are on your side and then ensure as a backstop. So, yeah. A lot of this is either our tooling and some of our outcomes, but with some adaptation to your realities. That part is there, right? There would be some things that are sufficiently weird that we can't cover with default tools. Any other reactions, questions? Okay, perfect.
Yes. So this morning I heard John Holquist talk about
Yep.
0 days, and he expects to see more 0 days here in the future. What should cloud users think about in regards to 0 days?
So there's a lot more exposed services, right? Again, discussion about data centers. If you if you expose a business application, or even a software as a service, like forget us. If it is 0 day in Salesforce API, it's kind of very little you can do as a client. Like they are exposed to the public by definition. That's why they're there. But apart from generic advice about red teaming, pen testing, and a few other things, there's nothing the client can do against the 0 day in a maybe not widely used cloud service. Providers can do a lot and do a lot. Apart from massive amounts of research that we do and other cloud providers do to uncover some of the stuff on our own, if it's a top tier cloud provider and they have a 0 day in a service, as a client, there's probably not all that much you can do. However, the IAM discussions often lead to this whole one IAM mistake away from a breach argument. And just as I don't want to be one IAM mistake from a breach, I also don't want to be one 0 day from a breach. So there is a degree of defense in depth that you can practice, and people have practiced. Defense in depth in the cloud is probably a separate multi-hour presentation, to be honest. And people there's an occasional vendor that basically says you don't need defense in depth in the cloud. And I want to violently argue with them, because for these situations, what you want is kind of defense in depth. And whether the layers are imperfect, again, the old cheese argument, right? There are holes in both layers, but they shouldn't match. If there's a Salesforce API 0-day, but you use Apigee gateway, and it probably has a 0-day too, but it's in a different API, and ultimately you are secure because you have layers. To me, this is where I would go. My mind would likely go to defense in depth as a safeguard. Because, I mean, even though I want to build more layers, but ultimately I'm not protecting every cloud API at my own expense. Kind of provide this job. But I will protect some of the top tier stuff with extra layers, for sure. Just as, again, the AI and LLM discussions come a lot, and a lot of people are nervous about both AI-specific attacks and the traditional application security attacks against AI-powered services. So there's a lot of proxy-type tech being bought to stick on top of the APIs. And you may have the API gateway and then another API gateway that's AI-aware. It's like, I don't know. Like, it starts to look like a firewall sandwich circa 2024. But yeah, there are reasons for it, and people are not buying it just for fun. Any other comments, questions, reactions? Well, I guess I'll know in the scores. If you can use any of this, you'll score it higher. If not, we'll see. Thank you very much for attention, and yeah, happy to do it.